Hey guys, we are back with 10.7, the addition rules for probability, where our learning objectives are to decide if two events are mutually exclusive, develop and use the addition rule for mutually exclusive events, develop and use the addition rule for events that are not mutually exclusive. So, as you may know, every member of Congress declares a single party affiliation, either Democrat, Republican, or Independent. Suppose that one commentator feels like a particular issue before Congress is most likely to be supported by women and Democrats. It would be useful to find the probability that any given representative is either female or a Democrat. At first thought, it seems reasonable to add up the number of women and then add up the number of Democrats in Congress, then divide by the total number of representatives. But if you think about it, this won't work. Those that are both female and Democrats will be counted twice. The situation would be simpler if the commentator were interested in the probability of a representative being either a Republican or an independent. The key difference is that any individual has to be one or the other. These two events are called mutually exclusive, which indicates that either one or the other must occur, but not both. So here's our first vocabulary word for this section. Two events are mutually exclusive if they cannot both occur at the same time. That is, the events have no outcomes in common. Okay? They cannot both occur at the same time. All right, let's look at our example. In drawing cards from a standard deck, decide if the two events are mutually exclusive or not. Okay? Drawing a 4 and drawing a 6. Drawing a 4 and drawing a 6. Well, every card has just one denomination, so a card can't be both a 4 and a 6. Therefore, the events are mutually exclusive. How about drawing a 4 and drawing a heart? Okay, well, you could draw the 4 of hearts, okay, which is one outcome satisfying both events. You can draw a 4 of hearts. That makes the events not mutually exclusive. Okay, so remember, mutually exclusive means they cannot both occur at the same time. You can't draw a 4 and a 6 at the same time. However, you can draw a 4 of hearts. That makes that not mutually exclusive. Okay? All right. Addition rule 1. When two events A and B are mutually exclusive, the probability that A or B will occur is the probability of A plus the probability of B. So our key word here is or. Okay. So if they're mutually exclusive, we'll add. See the word or, then we're going to add. All right, let's look at this in the works. A restaurant has 3 pieces of apple pie, 5 pieces of cherry pie, and 4 pieces of pumpkin pie in its dessert case. If a customer selects a random one kind of pie for dessert, find the probability that it will be either cherry or pumpkin. Find the probability that it will be either cherry or pumpkin. So the events are mutually exclusive. I'm going to just put mutually exclusive. Since there is a total of 12 pieces of pie, because we have 3 apple, 5 cherry, and 4 pumpkin, then we can write our fractions, or our probability of cherry. Okay, our probability of cherry plus our probability of pumpkin. Okay, our probability of cherry plus our probability of pumpkin. Well, since there are 12 total, we can say for cherry we have 5 out of 12, and for pumpkin we have 4 out of 12. When we add those up, we get 9 out of 12. Of course, we can reduce, and we end up with 3/4. Okay, so the probability will be either cherry or pumpkin. We have to find the probability of cherry, find the probability of pumpkin, and add them together. All right. Using the addition rule for 3 events. A card is drawn from a deck. Find the probability that it is either a club, a diamond, or a heart. Okay. Once again, I'm looking for my total of cards. In a deck of cards, we have 52, and you'll need to know this for a lot for the rest of this section and for the next section. That we have 52 total cards in a deck of cards. So in the deck of 52 cards, we have 13 clubs, we have 13 diamonds, and we have 13 hearts. Okay. And any card can be only one of those suits. So therefore, we're just going to find the probability of all of those, add them up. 13 plus 13 plus 13 equals 39 out of 52, which we can reduce by 13 over 13 and still reduce down to 3/4. Okay, so that keyword of is kicking off um, the fact that we have to add to find these probabilities. All right, let's look at another example. In rolling 2 dice, find the probability that the sum is 2, 3, or 4. 2, 3, or 4. All right, so in this one, we have to find the sum of 2 die, and we want to see when it can be 2, which is right here. When it can be 3, that's 2 plus 1. Remember, let me just clear this up for some of you. I'm adding because sum means to add. So I'm adding the two numbers together. 1 plus 1 is 2. 2 plus 1 is 3. 2 plus 1 is 3. 3 plus 1 is 4. 2 plus 2 is 4. 3 plus 1 is 4. That's as far as I can go because everything else is going to give me 5. Okay, the next the next sets will give me 5. So probability of getting 2, I have 1 out of 36. Probability of getting 3, I have 2 out of 36. And the probability of getting 4, I have 3 out of 36. Okay, literally, I just took this. 1 plus 1, that's 1 time. 2 plus 1 and 2 plus 1, that gives me 3. That's 2 times. 1, 2, 3. That's my 3 times for the last one. Okay, I see my keyword of, so I know I'm going to add. I get 6 out of 36, which reduces by 6 to give me 1, 6. Okay, and by the way, I knew my denominator was 36 because it's 6 times 6, so it's 36 total over there. All right, moving right along. Addition rule 2. When 2 events A and B are not mutually exclusive, the probability that A or B will occur is A plus B minus the probability of A and B. Now this and is actually going to mean multiply. And we'll see what this means in a second. All right, example 5. A card is drawn from an ordinary deck. Find the probability that it is a heart or a face card. Card is drawn from an ordinary deck. Find the probability that it is a heart or a face card. Okay. All right. So looking here, there are 4 kings and 26 red cards in a deck. There are 4 kings. Oh, I'm looking at the wrong problem. I'm like, that's not what that says. Sorry. We are looking for the probability that it is a heart or a face card. Okay, so probability of a heart. Sorry, I was getting thrown off trying to read ahead. Make sure I'm not missing anything. And then a face card. All right, probability of hearts. We have 13 hearts out of 52. Face cards. We have these are all face cards. 3, 6, 9, 12 face cards. So that's that 12 out of 52. Okay. And then we're looking at minus the probability of the heart and the face, which actually just be those three. So that's 3 out of 52. So we get 25 out of 52 minus the 3 out of 52. Okay, we took those out because we don't want to count them twice. I just realized I told you guys that this and was going to mean multiply. That's why I was reading ahead. I'm like, that's not, that's in the next section where we talk about that, 10, 8. So erase that from your head. We'll talk about and meaning multiply in the next section. It is not in this section. My apologies. Okay, so right now this and, the A and B just means where it's doubled at. Okay, where it's a heart and a face. Okay, so this and means heart and face. All right, so now we take 25 over 52 minus the 3 over 52, and we end up with 22 over 52. We can reduce that by 2, and we get 11 over 26. Okay, once again, I apologize. Do not look at that as multiplication right now. We will look at that and as multiplication in the next section um, when we talk about our multiplication rules. All right, but hopefully you guys still understood this problem. We had to find the probability of our hearts, probability of the face cards, okay, 13 total hearts, 12 total face cards, but then we cannot count them both at the same time. We don't want to double count them is what I'm trying to say. We counted these as hearts and then we counted them as face cards, so we had to take them back out again. And that's why we subtracted here. All right, example 6. Two dice are rolled. Find the probability of getting doubles or a sum of 6. Okay, doubles or a sum of 6. So we're going back to this table that we have. Okay, there are 6 ways to get doubles. Let's look at those 6 ways to get doubles. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So we can say 6 out of 36. Well, for our doubles, and then our sum of 6. So now when we add, let's change our color. Our sum of 6, 5 plus 1, 4 plus 2, 3 plus 3, 4 plus 2, 5 plus 1. So there are 5 ways out of 36 to get the sum of 6. Okay. And then we have to subtract a double and the sum of 6. Okay. Being a double and a sum of 6. There was one that we did twice, and that was this one here, the 3 and 3. That is our double and the sum of 6. So we can subtract that 1 out of 36. So here we get 11 out of 36 minus 1 out of 36, which gives us 10 over 36, which reduces to 5 over 18. Okay, so once again, when we're using this rule, when our events are not mutually exclusive. We start off with the probability of each one. We add them together, and then we subtract where they both happen at the same time. We subtract where they both happened at the same time. All right, one more example. Yep, last example. In a hospital, there are 8 nurses and 5 physicians. 7 nurses and 3 physicians are females. If a staff person is selected, find the probability that the subject is a nurse or a male. All right, so let's fill in this table. It tells us we have 8 total nurses and 5 total physicians. 7 nurses and 3 physicians are females. So in the female column, I'm putting 7 and 3. If a staff person is selected, find the probability that the subject is a nurse or a male. Okay, well, we need to fill in some of these missing spots. We're going to fill this in with 1 because we know we have a total of 8. Fill this in with 2 because we know we have a total of 5. That gives us a total of 10 here, 3 here, and 13 here. Okay, so now we have enough information to answer this question. Looking at the table, we can see that there are 8 nurses and 3 males. Because look, we're looking for a nurse or a male. Let me change colors. We have 8 nurses and we have 3 males. So we are looking for 8/13 because that comes out of here for the males. I'm sorry, for the nurses. 8/13. And then we have 3 out of 13. And then we want to see where it is a nurse and a male, which is here. Nurse and male, and that's that 1. Do the math. 11 out of 13 minus 1 out of 13 equals 10 out of 13. Okay, so the probability of being a nurse or a male is 10 out of 13. All right, that sums up section 10.7. If you guys have any questions, comments, or concerns, please make sure that you are emailing me. Read over your discussion problems. Make sure that you understand everything we went over. I know it's a lot of information, but we are making it work. You guys are doing awesome.